So, in this one, there's 10 questions on this quiz. So, the first one and the second one's really easy. It's just conversion. So, if I have x to the fifth over 7, what it's going to become is this is going to be 7 on the inside of the root, x fifth on the outside of the root, or right on the 5. I don't care which one you put it. But you are converting for question number 1 a simple exponent into what we call radical. Good. Number 2 is the reverse. So I'll give you the radical. Cube root of x to the 7th power. I rewrite that as x 7 over 3. That's question 1. That's question 2. Takes you less than 10 seconds. Question 3, evaluate. So I'm going to give you a question. You're going to evaluate. Now, you guys are very savvy with calculators. You can use your calculator. If not, I'm going to show you on hand in here, but I could also show you in calculator. Let's say if you had 27 to the 4 over 3, I would rewrite that as the third root of 27 to the 4th power. I asked myself, what times itself 3 times give me 27? Well, 3 times 3 times 3 does. So this over here is the same as 3 to the 4th power. 3 to the 4th power, 3 times 3 times 3 times 3, 81.
I have a question.
Yes.
You just look at the one to the left, and then you see like how many times it goes into it.
Yes.
If it was 27 to the 4, you have to be like how many
If
times?
you did it like this, so 27 to the 4th power, cube root, you could move the 4 to the outside.
No,
You,
switch it. I'm saying like it was.
oh, okay. Like this?
Yeah. So would you like be like how many times is 27 going to 4?
No, you would ask what itself 4 times goes into 27. So is it 2, 2, 2, 2? Is it 3, 3, 3, 3? But none of the things work, so it'll be clean numbers for
So
us.
if I plug that in, right?
You will get a crazy decimal, which means you made a mistake or something.
So would it be 81?
So it has to be a clean number. Yes, it should be 81 if you plug it in.
What if it's like not a number that like is to, that can be like square root to the third?
It will be a clean number.
Okay.
See at number 2, the 7 is like inside the square cube.
Yes.
Can I do like 3 right x like the rad x right, and then can I put parentheses and put 7 on the outside?
Yes, you could have did it with the 7 on the outside.
So like the parentheses and 7 on the outside are the same thing, but then what does the 7 distribute to the x and the 3? Like what?
No, they don't distribute like that. I understand what you're saying, but they do not distribute like that. This is technically a way to write 1/3 power. So 27 to the 1/3 power to the 4th power, which if you multiply is 4 over 3. Okay. Yes.
Like 3, is it number 3 like how many times you had to get from 3 to 27?
How many numbers I need to make 27? So I need a triple because it's 3. It was 4, I need a quadruple. Yeah. Yes.
How do we, if we had to get, like, let's say the thing was 81, and now 27, so it would be 4.
Yes. Yeah.
So it would be,
Like if I put 81 to the 4th root of 81, that'd be what times itself 4 times give you 81? That'd be 3 times 3 times 3 times 3. Okay? Kira, and then Shank.
So if it was like let's say 27 to like the 6th, then you would do 3 to the 6th power. That makes sense.
You would do like a 6 in the root?
No, like.
Oh, yes, you would do 3 to the 6th power. Yes. Shank.
Just how do you get the 3 square root of 4?
3 root of 27. So you ask yourself, or use your calculator, what itself 3 times gives you 27? 2 times 2 times 2 gives you 8. 3 times 3 times 3. No. Itself 3 times. So 2 times 2 times 2, because it's a 3. If it was a 4, it'd be 4 times.
For that part, always just take that 3 from there to begin with, and then
It is not. It's not divided by 3, Shank. I'll give you next, Ethan.
You see how you have this 3 over here?
Yeah.
So you just take that 3 and then that 4 and then
No.
That's what I'm saying. That's what I
If
thought.
I had this one, let's say, to the fourth power. Let's say this. Oh no, let's do it to the fifth power. Okay. If I had this one,
Okay.
I would ask myself, what 4 times itself? So x times x times x times x gives me 81. You try 2.
So
2
it
times
has
2.
to be 4 times.
For itself, yeah.
So this is always a 4. That's always a 4.
That happens to be 4 because this matches here. In this question, I asked myself, 81, what goes into, what itself 4 times give you 81? In this case, is 3. 3 times 3 times 3 times 3 is 81. You agree?
Yeah.
Then I take whatever exponent's here, in this case a 5, and put it on top. That's all it did.
Wait, but
Then I would do 3 to the fifth power.
how did you? Let's say you give us like not one that goes into it evenly.
I think
I will give you it that goes evenly. If it's real numbers, I'll give it to you evenly. Ethan.
Well, okay, to the right of number 3, and then to the right. When you right there, like in parentheses.
Here?
No, parentheses.
Here?
Yeah, why'd you write that?
I'll ask me a question about how it works. This is the same thing as saying 27 cube root, which is over here, to the fourth power. This is the same thing.
I don't think I know that, right? That's like
No.
How do you write it in a calculator?
You could write in your exponent 27 to the power 4 over 3.
So, for example, if you're gonna say straight up simplify, so you wouldn't mind if you just like,
It will say evaluate, but yeah.
okay, you wouldn't mind if you just took a calculator and just like entered in whatever it is, right? It rather than-
Yeah.
But let's say for that one, right? If I put 3, if I put let's say 27 cube root, right? To the 4.
Yeah.
So I don't have to. I can enter it like that, and I can just. So
You'll get the answer.
if you presented those 27 4 over 3, you can enter in a calculator and
You get 81.
got sure. For that, I'm say
No, you evaluated it. That's fine.
cool.
Yeah. All right, number 4. Again, I'm not going to talk over anybody, so. Let me do 4 and then I'll show you on the calculator. 4, evaluate this. Cube root of. No.
You're not.
Your homework's your review. 4. Oh, wait. Of 8 squared. Is it in the box? Then no, I have not got it in the box. So. That's my fault. It's just. All right, cube root of 8 squared.
64.
So the cube root of 64. The cube root of 64, aka what times itself 3 times, and that'll be 4. Yes. If you want to do it in your calculator, I could have rewrote this as 8, 2 over 3. Hey, I said I'm not talking over anybody. Stop talking back there. I'll stop the recording, and everyone can blame you. In the calculator, if you're going to do it in the calculator, you could change it into the exponent, 8 over 2/3, and then type into your calculator 8 to the power of, which is above the division symbol. So in this case, 8 to the power of, in this case was 2/3. So just put 2 divided by 3. Wait, what? Oh, no. I'm sorry. I messed up. This is... Oh, yeah, that is what I got for an answer. What am I saying? Yeah. 2 over 3 is that. Kira? And then,
The
yeah.
difference between this and the one that you did like for number 3.
This one I give you as an exponent. This one I give you as a root. But they're the same type of problem. Anyway. Yes, you could do it like that too. Which you could have got 2 and then square that. That will give you 4.
Can you go back to that?
Yes.
How do you put number 3 in a calculator? Like
27, 40.
What?
No, it's a different number 4.
No, but you have to keep using it and you have to get it and then do it.
Yeah, you want to convert it into exponent and then you can do it. Easy. All right. Yeah.
So see how the 2's in there, right? Inside the
Yes. You could have done it like this too. Cube root of 8 to the second power. Where you cube root first, 2 to the second power gives you 4.
No, but the cube root 8 is 2.
Yes.
Okay.
Okay. All right. Number 5. I'm going back on. Please stop talking. X to the 5th power equals negative 32. Yes. To get rid of a 5th power, what do we do? So I have to use a 5th root in order to get rid of a 5th power.
But it's a negative.
That's okay, because if it's an odd power, it's okay, because odd powers could be negative. So the answer here is just -2.
Is that what we
But 5 doesn't go. Wait, how did
Yes.
we go from 32 to negative?
Yeah, I didn't get
What multiplies times itself 5 times give you 32?
5 doesn't go into 32.
Ask somebody else, they'll explain to
2
you.
times 2 times 2 times 2.
If I had x to the 4th equals -16, and I 4th root it, this case, it is no solution. Or imaginary, but no solution. Because an even power cannot have a negative inside.
Would you like imaginary or something?
It would be imaginary, but
Is that like that power?
yeah.
Why is it for an odd exponent? It would work because like if we do -2 times -2 is +4 times -2 is so it's cubed. That's already
-8.
Number.
Yeah.
Yeah, they're saying at -2. Like how come it works for like this odd one?
Well, you do it. Do -2 times itself 5 times, so you get -32.
Yeah, but then it was negative.
So that's why it works. It works because it works.
That's no solution.
You said you can't negative inside the square root, but inside the root.
Hmm?
It didn't even say earlier that you can't have a negative inside the root though.
If it's even, you can't.
Why is it like, what's proof that even doesn't work?
Okay. Do, let's say it's 9. You ready? Okay. 3 times 3 is 9. You agree? Okay. -3 times -3, that's also 9. You agree? All right. Give me the same number, multiply to itself to give me -9. Is it possible?
No.
That's why. It's impossible for an even root.
But if you were to use anything else, it would still say the same state after 3 times or 5 times, 7 times.
That would work.
Right, that would work.
That's what I'm saying. That's why you could do it. You have to ask yourself, what itself 5 times give you -32?
not negative.
Check it out. Do the math out, and you'll see.
Would there be a no solution by the time?
Could be. This one, if it's x to the 4th to the 16th power, we're going to 4th root it. Because it's an even power, it's going to be plus or minus 2. Because it's an even power, it is plus or minus 2. Because +2 times itself 4 times give you 16. And -2 times itself 4 times equals 16. Because this was negative inside an even root, which is impossible.
So every even.
The even one is either going to be no solution or the plus or minus of it.
And the other one will just be whatever.
Always matching. So if it's negative, it's negative. If it's positive, positive. I guess I could do that here. The 5th root x to the 5th equals 5th root of 32. X equals 2.
So it's not be positive or negative?
It would just be positive 2. When it's odd, it's just the positive.
That's new. Why is that new?
That is not new.
That's not that.
What do you think it is?
There's just numbers on the outside and inside.
Okay. This is the question you would get. And then this is what you would do. You
Square both sides with like.
5th root both
Yeah,
sides.
I don't know how to say fifth root. I don't like saying fifth root.
Cool. Do it correctly though.
Wait, so if the exponent is negative and it's an even number, it's the same thing?
If the exponent is,
Negative. And it's an even number, it's the same thing?
we're not going to deal with negative exponents in this situation, so don't worry about that.
Is there a way to put the exponent on the outside of the thing? Like the square root? Like on the left side? Which is 5 square root.
In the calculator?
Yeah.
Yeah, you can check it out later. Or turn it into a fraction. No, it does not matter. They're equivalent, I should say. Number 6. X plus 7 to the 3rd power equals 27. Or you could get a version like this. X plus 7 to the 4th power equals, let's say, 81. So in this one, I would cube root both sides. So x plus 7 equals, this is a cube root. Guys, can you stop talking? No, the cube root of 27 is 3. And it's only positive 3 in this case. So -7, -7, x equals -4.
Why it's not plus minus?
Because negative 3 times negative 3 times negative 3 gives you negative 27.
Okay.
Here, though, this is a fourth root. Fourth root, this is an even root. What did we just say about even roots? Plus minus. So x plus 7
Why?
equals plus minus 3.
Wait, 4 root 3.
Yes.
Why would you do that?
Think about why a fourth root is both positive and negative. The same reason why square roots are positive and negative. So you're going to split this and solve. X plus 7 equals 3. And x plus 7 equals negative 3. Minus 7 minus 7. X equals negative 4. Minus 7 minus 7. X equals negative 10.
So either of those could be functions.
Yes.
Okay.
So you got to know how to deal with an even and odd.
We kind of did that in the other one also. With 5.
I know, but people would get really angry if I didn't show them exactly like this, so I'll show it exactly like this. Or I'll be claimed I'm a trickster, and I'm only a trickster sometimes.
Can you go back for a second?
My bad.
This is our last, like.
How are these different? How are the two you just showed us different?
No, we'll get one before break, but this is the last one for a while because holidays.
You say trouble. How are they? How are them two different?
This one,
Positive and negative, right? Is that
because of even power. Even power causes it to be plus or negative.
Why'd you decide to give this quiz?
Because I can't fit anything for the holidays, and then we'll miss a couple of things. So let me get this quiz in before giving you a test 4 weeks in the future about this stuff that we learned.
Is the
Thinking.
the 2.8 on it?
2.8. I'll turn back on.
The one that we weren't at.
No, that will not be on it. Very important. That's not on. All right, number 7. Some exponent properties. X to the 3 tenths times x to the 12 tenths. What do you do when you multiply exponents with the same base?
You add them.
You add them. So remember how you add fractions. You add fractions by adding the tops. So 15 over 10. Simplify that to x 3 over 2. Simplify if possible.
What if they don't have the same base?
You cannot do anything. Or I'm going to show you a question where they don't have the same base, and what does that mean?
Will that be on it?
Yeah. 8
Is it
x to the 3 halves divided by x to the half. When you divide, what do you do? Subtract. X to the 2 over 2, just x. All right.
Can you give an example?
Were you dividing or
Subtract them because you're dividing.
2 minus 2?
Are we gonna give an example for the different denominators? Are we gonna do it for the different denominators?
No, when you add and subtract fractions, you don't mess the denominators. And I'm not going to make you change denominators if that's what you're asking.
Yes.
8 root 3 minus 6 root 3. In this situation, the root 3's is kind of like a variable. If you had 8x minus 6x, what would you do? You would get what? 2x. So in this case, 8 root 3 minus 6 root 3, just 2 root 3. Nothing complicated about that. Nothing complicated about that. For an answer for this.
Someone's gonna overthink that.
I know. Some people would put just 2, and they're going to get it wrong.
Can I just like review this in order? Like,
It's literally in order, yes.
okay, thanks.
Is the problem with exactly?
Different numbers. This one, I have to think about how to make this one. 15 root 3 plus 7 root 18.
You take out like the one in common. You divide by 3.
All right. So in this one, something's wrong because number 9, they match, so you could just subtract them. This one, they don't match.
Were you just common factor?
So let's look at this 18 one. 3 is definitely prime. We can't do anything about that. But this 18, and we're doing square root, I could have a 3 or a 4 in here. But here, this is a square root. So this is 18. I could break this down 9 and 2, which I could break down to 3 and 3. In this situation, go ahead. If this is a square root, I could take a pair and let it leave on the outside. So, on the outside, I'm going to times a 3. A single 3 because it's a pair. So it's a single 3. What's left over on the inside? Just a 2. Oh, wait a second. I messed up the question. Give me a second. All right, you know what? Keep it like that. Just change this to root 2 so it works. Okay. So either way, then this is going to become 3 times 7 is 21. Root 2 plus 15 root 2. My bad, that's why I messed up. It has to be the same. So then, because the roots match, you just add them. 36 root 2. Yes.
That's it? Yeah.
Wait, I have one question. What happened to that 2?
I have to change it to 2 so it matches. When you do this, it should match. Oh, the blue 2? It just leaves right here. It just stays. I'm just showing that it's a square root, so you need a pair. If you had a cube root, what would you need? You need a 3 of a kind, right? If you had a 4th root, you need a 4 of a kind. 5 root, 5 of a kind. So it changes based on the question. Huh?
Wait, how did the inside of the 18 become a 2?
3's left because there's a pair of them. 2 is the only thing that's left over. So that's why there's a 2 left over.
Wait, what do you mean, like 3 of a kind for a cube?
So let's say let me give let's call this 10b. Let's give it another version, okay? Let's do 3 cube root of 2 plus. They asked if it was a cube, so let me do this. 7 cube root of you could do 80. Wait. And I'll make this, my bad. Let's make this a root 10. So make it, they have to match. Or otherwise, there's no math to do. Not on this quiz, no. If it was a test, I would. On quiz, no.
Is that the only one where there's going to be like a different type? Now, is there going to be like a 60 or like is it just
No, there will be a question 10. I'm just saying this is like a version of a 10 question.
But like everything else, there's no other version.
Well, the 6-7 we just did? No. 9, 8, 7. The 6-5 we did, where we had the odd root or the even root. Technically, there are multiple versions, but you only get one version.
There's nothing else?
I don't think so. I think I covered everything, if that's what you're asking. I covered everything.
Okay.
So I'm going to break down this 80 to 8 and 10. I'll break down the 8. This is a 5 and a 2. 2 and a 4. 2 and a 2. So in this case, I have a triple 2. And I need a triple. Guys, shh. Someone asked me a question on what if it was a cube root. Please pay attention. So, if it's a cube root, I need a triple 2 to leave. I need a triple 2 in order to take it to the outside and 2 times on the outside. What's left over is a 2 and a 5. So the inside will multiply to each other. So 3 cube root of 10 plus 14 cube root of 10, which means the result is 17 cube root of 10.
Are we gonna give us a problem like that?
It's either this or that. Like, this is how it's going to look like. I could do it to the 4th root, the 5th root.
For this one, why did you keep 1 and 2 on the outside?
What's up?
You kept 1 and 2 on the outside.
Because this 2 does not have a triple to go with it.
It's in triples now.
Because it's a 3 root, you need a triple. If it was a 4 root, you need a quadruple.
This is OD.